so problem 14. We know we have a 30, 60, 90 triangle. So we have a right triangle, that means we can do SOHCAHTOA. Hey, there's 2 packages of things.
Instead of like cards
Yes.
in there.
Yeah, just take them both to them.
So the card just goes with the thing.
Yep. Thank you so much.
Yeah, thank you.
So the longest side is 11. Longest side would be your hypotenuse. And we have to find the other 2 sides. So you can label them whatever you want. So if I were looking for this side, that's across from my 30-degree angle. So that's opposite. 11 would be hypotenuse. So you could either do the sine of 30 or the cosine of 60. Sine of 30 is 1/2. So if we multiply that 11 over x is 11 halves, or 5.5. So that's one side. If I wanted to do the other one, if I were looking from my 30-degree angle, this is adjacent and hypotenuse. So that would be cosine, my adjacent side over my hypotenuse. Cosine of 30, radical 3 over 2. Multiply over the 11, we get 11 radical 3 over 2. Oh, once you got one of the sides, you did it, that'll work. Yep, no problem. Did you get the same thing? Yeah, so you did this side first and, or, oh, you just didn't keep it, you did the decimal. Keep it an exact value, which would be easier if you did that as a fraction. So then you have to break down your radical. So you're looking for a perfect square that goes into 363. So you would break it in 2. Instead of a decimal. 21 and 3. 31, 21 is 11. You're welcome. Alright, problem 15 is just picking your quadrant. So we think about the all students take calculus. First requirement is that cosine is positive. So they're all positive in 1 and cosine's positive in 4. So we know it's either 1 or 4. The second requirement is that tangent is negative. They're all positive in 1, so that wouldn't work. In quadrant 4, cosine's positive and tangent is negative. So quadrant 4 is the correct answer there. Problem 16. We know we are in quadrant 3. Remember when we draw these triangles, it's always coming out from the center. So I noticed some issues with drawing them yesterday. In quadrant 3, it would look like this, but that's what it looks like in the other quadrant, so it's always coming from the center. So in that, we know that tangent is 3/4. So if you think about your SOHCAHTOA, tangent is opposite over adjacent. So my opposite side is 3, my adjacent side is 4. However, if you're in the 3rd quadrant, what's true about both of those numbers? They're both negative. So then we could do Pythagorean theorem. So 9 plus 16 is 25. Square root, so this side is 5. So now we're looking for secant. So that's the reciprocal of cosine. Cosine's adjacent over hypotenuse, so secant would be hypotenuse over adjacent. So negative 5/4. Is that okay? So on 17, we have to think about quadrants and reference angles. Because I said exact value, that means not what your calculator would tell you. Okay, we want the value with radicals. So we have to first think, 225 is in what quadrant? Quadrant 3. Reference angle. Yep, 225 minus 180 is 45. So in quadrant 3, tangent's positive, so that means sine is negative. The sine of 45 degrees, radical 2 over 2. So in this one, same thing, it's just in radians. What quadrant is 5 pi over 6 in? 2, because the top is 1 less. Reference angle is pi over 6, or you could think of that as 30 degrees. In quadrant 2, remember secant's the reciprocal of cosine. Sine is positive, so that means cosine and secant would be negative. The cosine of 30 is radical 3 over 2. So if you flip that, 2 over radical 3, so that's negative 2 radical 3 over 3. With the negatives, we typically try to make it positive first. So we know if it's degrees, you add 360. If it's radians, you add 2 pi, finding that coterminal angle. So 3/4 plus 2 is 5 pi over 4. All right, this 4 is just going to get multiplied along. What quadrant is 5 pi over 4 in? Third. Reference angle is pi over 4, or 45 degrees. In quadrant 3, tangent's positive, so cosine's negative. Cosine of 45 degrees, radical 2 over 2. And then when you multiply it by 4, you can reduce it to, so you get negative 2 radical 2. On any of those questions, you can use your unit circles to get those as well. Just make sure that you're able to fill out the unit circle. Problem 20. 5 pi over 12. That is not one from our circle. So what we typically did first is just changed it into degrees. So if you multiply by 180 over pi, the pi's drop. 5 over 12 times 180 gives us 75. And so then we had to think about angles that add or subtract to 75. 75 is 30 plus 45. So cosine of A plus B. So you can look at your formula sheet or our flip chart. So that is cosine of the first, cosine of the second, minus sine of the first, sine of the second. So it's the cosine difference. But now it's hand trick. What is the cosine of 30? What's the cosine of 45? Sine of 30. Sine of 45. So if you multiply radical 3 times radical 2 is radical 6. 2 times 2 is 4. 1 times radical 2 is radical 2. 2 times 2 is 4. You can leave it like that. If you put them together, you can't actually subtract them. You could just make a single fraction. But either of those answers would be okay. The next chunk of problems is all using identities. So 21, there are a couple different ways to start Most people say cosecant is 1 over sine. Cotangent. Some people change these to sines and cosines. Some people change them to tangents. Which way did you guys go? Okay, so cotangent is cosine over sine. Tangent is sine over cosine. So this one's like a sine x over 1. To divide fractions, you flip and multiply. So if you multiply the tops, that's 1 over sine squared x. Cosine times cosine is cosine squared x. Cosine squared x. Again, from here, I saw people taking a couple different options. You have a common denominator, so some people went ahead and put those together in one fraction. Some people turned like 1 over sine squared into cosecant squared, and cosine over sine into cotangent squared. Do you guys have a preference? No? Okay. If you did the common denominator, what's 1 minus cosine squared? And sine squared over sine squared. So this one we told you to start with sine and cosine. So 1 over cosine is equal to secant. Tangent is sine over cosine. And it's just times a sine x. So if we multiply, sine times sine is sine squared over cosine. These have a common denominator. What's 1 minus sine squared x? What's cosine squared divided by cosine? That would be our question. Three. So, I wanted to simplify this. What did you guys do first? Tangent is sine over cosine. What is cotangent? This is just a regular cosine. If you want, you could say it's over 1. Either way. If I distribute, you don't have to write this step, but I'm going to just to show you what I'm doing. I multiply this. The cosines drop and the sines drop. If everything drops, we put over here the cosines drop, and so we have minus sine. Is that an identity? No, it has to be 1 minus sine squared to be an identity. So that is our final answer. Alright, so now we have the proofs, which are essentially the same thing, but a little bit easier because you know what the answer is supposed to be. So I'm assuming everybody probably boxed in the 1 here. And if I'm looking at this side, there are a lot of different things you could do first. What did you guys see? What did you do first? Okay. Alright, from those Pythagorean identities, 1 plus tangent squared is secant squared. 1 minus sine squared x is cosine squared x. Secant is 1 over cosine squared. So if you have cosine squared on top and bottom, they cancel. Let me just get one. Okay, for 25, if we want to add or subtract fractions, what do we have to have? So this one currently has a denominator of 1 minus cosine. If it's going to look like the other, it needs 1 plus cosine. This one is 1 plus cosine. To look like the other, it needs 1 minus cosine. So then if we FOIL, we get 1 plus cosine x and plus cosine x would be 2 cosine x. Cosine times cosine is cosine squared. On the bottom, if you get 1 plus cosine and minus cosine cancel. Minus cosine squared x. Same thing for the second fraction. When you FOIL, you get 1 minus 2 cosine x plus cosine squared x. Bottom is 1 minus cosine squared x. If we are subtracting, what do we need to do? So then 1 and negative 1 cancel. Cosine squared and negative cosine squared cancel. So 2 cosine plus 2 cosine is 4 cosine x. Over the denominator, 1 minus cosine squared. Except what is 1 minus cosine squared? Sine squared. So what that means, sine squared is just like a sine times a sine. So we have a 4. You have a cosine divided by sine, which is cotangent. And then we have a sine left on the bottom, or you could think of it as 1 over sine, which is cosecant. So 4 cotangent x, cosecant x. Is that all right? The last two are graphic. So remember when we graphed, we had a series of things we went over. Amplitude, period, count by, interval. Your amplitude is the number in front. So my amplitude is just 3. Period is your normal period, which everything except tangent and cotangent has a normal period 2 pi. You have to go all the way around the circle before it repeats. Divided by the number in front of x, which is a 2. If we divide that, we get pi. Count by takes your period that we just found and divides it by 4 for the 4 quadrants. So we're counting by pi over 4. The interval. Everything except tangent and cotangent just gets set up between 0 and 2 pi. And you put your angle in the middle. 2x minus pi over 3. Is this coming back a little bit? Okay. So this interval, we have to solve for x. So if we add pi over 3 to everything, pi over 3 less than or equal to 2x less than or equal to 7 pi over 3. Divide everything by 2 or multiply by a half, and we get pi over 6 less than or equal to x less than or equal to 7 pi over 6. So to graph this, I asked for 1 period only. So remember we had to have a total of 5 points. You're starting and then 4 more. I am starting at the first place in my interval, which is pi over 6. And then we have to add or count by to get the additional points. So you're adding pi over 4. If you struggle with that, I told you you could do like 1/6 plus 1/4 on your calculator and get it that way. Just don't put in the pi's. So that would be 5 pi over 12. Then if we add pi over 4, 8 pi over 12, which would reduce to 2 pi over 3. Add pi over 4, so 11 pi over 12 plus pi over 4 would be 15 pi over 14 pi over 12, which reduces to 7 pi over 6. And you notice that is where we set our interval would end. Amplitude is 3, so my high point will happen at 3, my low at negative. Cosine starts at its high point. Think about cosine of 0 is 1. It starts at its high point, which is 3 here. Then it goes down to 0, to its low point, back to 0, and high point. Remember, you just bounce back and forth with sine and cosine. You're bouncing back and forth between high, middle, and low. This is a curve, so when you're drawing it, try to make sure it's not a zigzag. And get something like that. Last one. I'm not going to get all the way through grading, but close. What does this negative 2 in front do? The negative in front of my 3 flips it. This is the same thing as if I wrote negative 3 tangent x minus 2. So it is going to flip because the negative in front of my 3, and my minus 2 will take it down 2. Okay, amplitude. Amplitude is always positive. It's just the number in front of tangent. The negative makes it flip, so the amplitude is just 3. Period. Tangent and cotangent have a normal period of pi. Divide by the number in front of x, which is just 1, so our period is pi. Count by is always whatever you get for your period divided by 4. Interval. Tangent and cotangent are weird. What interval do we pick for tangent? That's cotangent, goes from 0 to pi. Tangent is from negative pi over 2 plus pi over 2. Because remember, we do tangent, inverse, and quadrants 1 and 4. So that's why we picked that. Okay. This one doesn't have any other left-right movement, so we can draw this. My first point will be at negative pi over 2. Add pi over 4, that takes me negative pi over 4. Plus pi over 4 is 0. Plus pi over 4 is pi over 4. Plus pi over 4 is pi over 2. And because we went down 2, we usually just showed that by drawing a dashed line there. So this is going to mark the center of my graph. Since my amplitude is 3, we'll be going 3 above and below that line. So my highest point would be at 1, my low at negative 5. Okay, we picked this interval for tangent because your vertical asymptotes show up on the ends. So both ends are vertical asymptote. And your 0 point is on the middle, which is at negative 2 here. Tangent is increasing, but because we flipped it, it'll be decreasing. So at negative pi over 4, we'd be at 3 above that line. Positive pi over 4 would be 3 below. graph looks like that.